Hello viewers, welcome back to my YouTube channel. First of all, thanks to every one of you for watching my videos and also for subscribing my channel. In this video, I am explaining the concept of network analysis, which is also known as project management by CPM and PERT. Project management by CPM and PERT. What is meant by a project? Look at this. A project is a network of some interrelated activities connected in a logical and sequential manner. Look at the definition one more time. A project is a network of some interrelated activities connected in a logical and sequential manner. Second point to know before going for a network. See the second point. PERT and CPM are two network analysis techniques used in planning and controlling projects. What is CPM? It is critical path method. CPM is critical path method. What is meant by PERT? Program evaluation review technique. One technique is CPM, which is known as critical path method. The other one is PERT, program evaluation review technique. Okay. Since a project is having some interrelated activities, each activity consumes some resources and will also take time for their completion. Look at this point once again. A project is having some interrelated activities, so each activity will take time for their completion and also consume resources. When the times of all the activities are given, length of each path is determined. The longest path is called critical path and the activities on it are called critical activities. Okay. Besides the project duration, scheduling times of various activities are also determined. What does it mean actually? Earliest start and finish times are obtained by forward pass calculations, and the latest start and finish times are obtained by backward pass calculations. This is a brief introduction about network analysis. Now let us see how to draw a network. How many activities are involved? Each activity will take how many days? Also, each activity is dependent on whom? When this type of information is given, I can calculate the starting time and finishing time of each activity and also length of the project. For that you need a network diagram. This is what? A scheduling technique. What is a scheduling technique, sir? Scheduling is nothing but calculation of starting times and finishing times of various activities which are involved in the given network. So let us see how to draw the network for the given question. How many activities are involved in the given question? 1, 2, 3, 4, 5, 6, 7. So a small project is having 7 activities And what is the information given? Which activity is dependent on whom? What is the duration of each activity in days? So which points you have to keep in your mind when you are drawing a network? What first row will represent? This first row will represent the number of activities which are involved in the given network. There are 7 activities which are involved in the given network. They are represented with A, B, C, D, E, F, G. Next, what is second row? What it is indicating? First row activities can be started after completion of which activity? Look at this. Activity D can be started only when activity A is completed. Activity E can be started when activity C is completed. Activity F can be started when A is completed. We can start activity G when D, B, E are completed. Clear? Next, activity A will take 4 days. Activity B will take 6 days. Activity C will take 2 days. Activity D will take 5 days. Activity E will take 2 days. Activity F will take 7 days. Activity G will take 4 days. This way, time required for each activity to complete is also given in the question. Using this information, first you have to draw a network which is called planning. Calculation of earliest start and finish times. Calculation of latest start and finish times is called scheduling. So planning and scheduling will take place before starting the project. Again, I am repeating this point. Planning and scheduling will take before starting the project. Now, how to start the network? What are the points we have to keep in our mind when we are drawing the network? First point is, each network is having only one initial node and one terminal node. I am repeating this point. Each network is having only one initial and one terminal node. Second point is, start the network with independent activity, otherwise independent activities. What is an independent activity, sir? Independent activity is one which is not dependent on any other one. Here A is an independent activity, whereas activity D is a dependent activity. What is the meaning of this? You can start A immediately. That is called independent activity. But D can be started. Only when A is completed. So D is dependent on the completion of A. Similarly, E is dependent on the completion of activity C. Here, activity G is dependent on the completion of 3 activities D, B, E. That is the meaning of independent and dependent activity concept. So, first point is, network is always started with independent activity. So let us see. Here three activities are independent A, B and C are independent activities. So simultaneously I can start these three activities. Simultaneously I can start these three activities. So this is activity A, this is activity B, and this is activity C. Three activities are simultaneously started. Three activities are simultaneously started. Clear? Now after that, see the question. When activity A is completed, which activity I can start? Activity D and activity F. Activity D and activity F can be started. If I take this as activity A, this if I take as activity A, this as B and this as C. When activity A is completed, two activities D and F can be started. This is activity D and this is activity F. Clear? Next, when activity C is completed, you can start activity E. When activity C is completed, we can start activity E. Here activity C is completed. Then I can start activity E. This is activity E. A, B, C, D. Activity A, activity B, activity C, activity D, activity E, and also F. Planning is over. Now to start activity G. To start the activity G, how many activities are to be completed? Activity D, activity B and activity E are completed. Then only you can start activity G. Now, what is the meaning of this point here? For this activity G, there are three predecessors. For this activity G, there are three predecessors. So, first of all, join these three activities at one node. The same point I can say in another way. When any activity is having more than one predecessor, then these predecessors are joined at one node. Look at this. This is activity B, this is activity D, and this is activity E. These three activities I have to join at one node. These three activities are joined here. Activity B, activity E, and activity D are joined at one place. Now after this, which activity is coming? From these three, means the activity D, activity B and activity E, where these three activities are merging, activity G is coming. These three activities are merging here, therefore activity G is coming. Now look at this, sir. After this activity F, there is no other activity to perform. Therefore, join this activity here. This activity F, where I am merging, this way activity F is merged here, because each network is having only one initial and one terminal node. After this activity F, there is no other activity to do. Therefore, activity F is merged at the terminal node. So, here all the conditions of the network are satisfied. Activity A, B, C are independent activities. Look at the question once again. The three activities A, B, C are independent activities. So the project is started with three independent activities A, B, C. The project is started with three independent activities A, B, C. When activity A is completed, we can start two activities D and F. Therefore, when activity A is completed, two activities D and F are started. Next, when activity C is completed, we can start activity E. When activity C is completed, we can start activity E. Look at this. When activity C is completed, E started here. So, terminal node of this activity is initial node for this. Next, look at the activity G. Activity G can be started only when activity D, activity B and activity E are completed. So, for activity G, there are three predecessors. D, B, E. These three predecessors, first we have to join at one node. Look at this, activity D, activity B and activity E are joined at this node. Then activity G started. This is merging node. Now sir, after this, look at this activity F. Once activity F is completed, there is no other activity for whom F is a predecessor. Again I am repeating this point, there is no other activity for whom F is a predecessor. Therefore, F is joined at the terminal node here. This way a network is constructed. Now look at this. A is an activity, it is a work element. B is an activity, C is an activity. Each activity in a network is represented with an arrow diagram. Each activity has two nodes, starting node and finishing node. For activity A, this is the starting node. For activity A, this is the starting node and this is the finishing node. For activity B, this circle is the starting node, this circle is the finishing node. This way we have to interpret. Now in addition to this information, what is given in the question? Activity A will take 4 days. Activity B will take how many days? B will take 6 days. Then activity C will take how many days? 2 days only. Duration of each activity I am representing on the network along with the activity B. So the numbers I am writing within the brackets will represent what? Duration of each activity. Next, activity D will take 5 days. Activity D will take 5 days. Activity E will take how many days? 2 days only. E will take 2 days. Activity F will take how many days? 7 days activity F will take. And activity G will take only 4 days. G will take 4 days. This is the network given. That is, for the given elements, a network is drawn. Now, sir, once the drawing of network is over, we will calculate the time required to complete the project. Planning stage is over. Now I am moving to scheduling stage. Before that, let me see how many paths I have to complete. And each path will take how many days. So for that, let me give numbers to these circles. Numbers to these circles. Numbering is always from the left hand side, and we are moving to the right hand side. For numbering, always start from the leftmost circle and move to the rightmost circle. Second point, when you consider any activity, we know for each activity there are two nodes, initial node and terminal node. The number assigned to the head node is always greater than the number assigned to the tail node. So this is the tail node 1 I am giving. This is the head node 2. For this activity C, 1 is the tail node, this is the head node, so I am writing 3 here. For this circle, that is for activity D, activity B and activity E, this is the head node. So the number I am assigning here is greater than the numbers already assigned to the previous nodes. So this is equal to 4 and this is 5. Numbering is also over. Numbering is also over. Now let us see how many paths the project is having. So let us calculate path and its length. Path and its length. Activity A, activity F consists of one path. Activity A and activity F is one path. What is a path in a network? Starting from node number 1, in how many ways I can reach to node number 5. Again, this point I am repeating. Starting with node 1, in how many ways I can reach to node 5. So one path is AF. It will take how many days? 4 plus 7, 11 days. 4 plus 7, 11 days. Another path is ADG. Another path is ADG. A will take 4 days. D will take 5 days. And G will take 4. 4 plus 5, 9. 9 plus 4, 13. 13 days. Next, one more path BG. This is also one path. B will take 6 days, G will take 4 days. So this is 10 days. Last path is CEG. CEG. Activity C will take 2 days. Activity E will take 2 days. Activity G will take 4 days. 2 plus 2, 4. 4 plus 4, 8. 8 days. This way, for each path, length is calculated. For each path, length is calculated. The path which is having longest duration is called critical path. The path which is having longest duration is critical path. First path is having 11 days. Second path is having 13 days. Third path is having 10 days. Fourth path is having 8 days duration. So 13 is the longest duration. So this path is called critical path. And see critical path how I am writing. A, D, and G. This is the critical path, and the activities on it are called critical activities. The activities on this are called critical activities. And length of the critical path will decide duration of the project. What is the importance of critical path? It will decide the duration of the project. This project will take 13 days. This project will take 13 days. Over. This is called planning of a network. So in the next video, I'll tell you how to calculate earliest start time and earliest finish time of each activity by forward pass calculations, and also latest start time and latest finish time by backward pass calculations. That's all in this video. Thank you.